Hi and welcome back to Small Caps. My name is Jess Fertig, and today it is my absolute pleasure to welcome Latrobe Magnesium Limited. The company's ticker code is LMG. Joining me for an interview today is the company's Chief Executive Officer, Mr. David Paterson. Hi, David. It's lovely to have you on the show.
Morning, Jess. It's good to be here yet again.
So, Dave, now firstly, congratulations. The company has just put a major milestone announcement out this week. But before we get into the details and discussion on this, for our Small Caps audience, can you just provide a brief overview of the company and also just briefly elaborate on this exciting achievement?
Well, we're all about basically producing magnesium metal from brown coal fly ash, and that's a first in the world, as we said today. So it's something that we've been working with a lot of laboratories, a lot of people like CSIRO for a number of years. Today, on Sunday, I suppose, we produced our first mag oxide. And mag oxide is important for us because what that does is, given we make a very pure mag oxide, it's very easy to make magnesium metal for that. We've done it many times before in the lab, and there's no big problems that you get associated with that back end. It's really automation that we use in Australia versus a technology that's been used since 1941. So there's no big differences, but the big differences is taking out all the minerals that are in the fly ash at the front end. And that's about 4 different minerals that we then sell. We make into valuable products, and we've got offtake agreements and discussions with off-takers for each of those products. So that's the thing that does 2 things for us. One, it provides us with additional revenue so we can actually compete against China. 2, it ensures that we don't have any waste from our process, because traditionally what you have in China, if you're making magnesium from dolomite or magnesite, you'll make 1 ton of magnesium and 9 tons of waste. We don't make any waste. So a lot of people, you talk about circular economies and they talk about it. Fact is, we do it. And as I said, because our cost base is a bit higher to start with, but of course you get 25% of our revenue from those other products, that then makes us competitive.
Fantastic. Now,
so that's what our Hydromet, by making the mag oxide, proved we could take out those 4 other products because they come out before you make mag oxide.
Fantastic, Dave. Sorry for interrupting you over there. Now, so you've mentioned some of these benefits, which are very, very exciting, and we'll get into more of those details just now. But can you elaborate on some of the specific challenges that you have overcome or been able to overcome during the commissioning phase of your demonstration plant?
Well, it's like any demonstration plant, because this is a first. What we've done in our Hydromet system was we put fairly proven chemical. It's like a big chemistry set, if you like, big one. So what we do is we put well-known processes in an order that haven't been done before, of course, because no one's ever treated fly ash before, brown coal fly ash. So most of the processes are well-known processes, but then you've got to put it into a plant, and you have many pumps, many filters, many tanks, and those situations, and it has to flow freely through that system. Then the other thing we do is we make a mag chloride, and that mag chloride has gone into a big spray roaster. The spray roaster is pretty much similar to what it sounds. The only difference is it's 30 meters high and about 8 meters wide. And you spray the mag chloride in from the top, goes onto a roasting bed, and you inject water on the way through, and water being H2O, the mag connects to the water. The oxygen connects to the mag, and therefore we make mag oxide down the bottom, and the hydrogen collects with the chloride, and you recirculate the hydrochloric acid because it's an expensive thing to use. So we do a whole recirculation in that process. We use some of the best well, I think number one or two people in the spray roaster business in the world. Some basic Italians. They got factories in Austria and Leipzig, Vienna and Leipzig, and even in Vietnam. And they produce these products, these bits of equipment worldwide, but not usually for making mag oxide for magnesium. They usually make mag oxide for pharmaceutical grade that everyone knows about. You have your mag pills if you've got bad lesion, you have arthritis or things like that. So they make a very high quality mag, which is what we want, mag oxide, which is what we want to put in our second part of the process.
Yeah, thanks, Dave. That's so interesting. And magnesium also very good for runners. And I'm only saying this because I'm actually looking to do the Sydney Marathon later in the year. So who knows? I don't know if you can get this into production as soon as that, but we'll certainly be keeping an eye out for that. Now, David, Latrobe's hydromet process sounds really promising. How does it compare to traditional magnesium extraction methods in terms of environmental impact and also production cost?
So environmental impact, as I mentioned before, I usually start off by saying I love my feedstock. It's difficult to process and it costs you more to process, but then you get, as I mentioned earlier, the revenues. The big difference when you start talking about emissions in magnesium, they call it the green metal because it's lighter, stronger, cars go further, less emissions, and electric vehicles go further because it's lighter and therefore the battery lasts longer. Right, so they call it the green metal because of that. But the big problem has always been the amount of CO2 that you produce in the primary production of the metal. And because China uses effectively mag carbonates, MgCO3s, and we use a mag oxide, there's a massive difference because the first thing you do when you make a mag, 1 ton of mag from a carbonate, is you send the CO2 up in the air. And it takes 10 tons, as I mentioned earlier, for 1 ton. So that's 10 tons of CO2 that goes up in the air. We use mag oxide, nothing goes up. Well, there's no CO2. So the beauty about it, we have a 10-ton walk-up start on any other production, which is very important when you get down to the metal at the back end, because everyone that wants to use it in mainly aluminium sheet for cars and aluminium cans is the CO2 emissions profile, because everyone wants to decarbonize worldwide. So very important. Mags is a critical mineral because China produces 1 million tons of about 1.1 million tons. There is no producer in Japan. There is no producer in North America. That's Canada and USA and Mexico. Sure. And EU, there's no producer in the EU, no producer in the Middle East. So you've got these basically making 1 million tons in China, 500,000 going off to other places, and people are very wary of their supply chains. And there was a supply chain incident back in late 21 where China closed down that export market and everyone couldn't make cars. They ran out of mag and they couldn't make cars. So people don't mind. Well, there was a price rise that went 3 times. It went sort of from 3,000 to 11,000, but it was really about having the material, because to make a car, make all your body and all those sheets, your hoods, your doors, your bonnets, you need 5% mag. Otherwise, it would just dent very simply. Aluminium cans, initially when you had an aluminium can or a beer can, everyone you'd be able to rip them, but if you palletize them, they'd squash. So they put 1 to 2% mag in the sides, and they can palletize them and they won't squash. Beauty about also magnesium and aluminium mixed together, you can recycle it. It's 100% recyclable. So you're getting the best of all worlds, really. But as I said, our hydromet system is one of the lowest CO2 emissions. It's 60% under industry average. And therefore it's one of the things that help us sell that magnesium worldwide. But it's very easy to sell magnesium if you make a good product and a low emissions standard, because, as I mentioned before, with those number of countries that don't have producers, it's supply chain. So it's a critical mineral supply chain, which all the governments are talking about. We actually have it. We experience it all the time. So, we're talking to very interesting companies, very big companies, I'm sure, about putting in, fixing that supply chain for them. And we won't fix it because, even we talk about going through our 1,000 tonne, then 10,000, then 100,000. But everyone says, 100,000 is $1 billion plant. But everyone goes, oh, that's big. How's that going to affect the market? The market demand is growing at such a rate. Usually grows about 100,000 a year. So China still has to go from 1 million to nearly 1.8 million tonnes, and we'll come in at 100,000 for the rest of the world and 100,000 of ours. So it's not really affecting the market that much or affecting China that much. It's just a better product because of the feedstock in a lot of cases.
Yeah, so interesting, Dave. And this project could potentially be, very, very important for national security of supplying critical minerals. As you mentioned, the Western world and Western governments are really looking to secure the supply chain of their critical minerals. So this is obviously a very important project and significant milestone for the company, as you mentioned. So you mentioned aluminium, so I want to chat a little bit about the byproducts of your process, so which is very interesting. Can you explain how Latrobe will capture the full revenue potential of those secondary materials?
Yeah. So our process, we purposely do it when we make our magnesium. We actually add other consumables in there, and we make what we call a supplementary cement material. So in the cement business, the biggest polluter in the world, they make usually 1 tonne of CO2 per tonne of cement. We can actually deliver up to them a product that's the same chemistry and mineralogy as Portland cement. When you put 30% of our product together with theirs, they can call it eco cement because they've just dropped their CO2 profile from 1 tonne down to 0.7 of a tonne, and they're looking to decarbonise like every other major industry. But they're the biggest selling product worldwide. So it's I don't know how many million tonnes, but there's a lot, probably billions, probably. But I haven't caught up with that lately. But that's our second biggest product. We have things like a very good iron product for the fly ash from your lawn, and we're talking about using that in a desalination plant and a normal water treatment plant as a flocculant. So it sits on top, takes off all the materials they want to filter out and captures it. So we use it that way. So you've got it's an iron oxide. We talk about char. All these products are basically CO2 zero. So, it's great when they use it because it just means that they can, put their hand up and say they're looking down the road for their decarbonisation. So that's 2 of our main products. Char and silica come out of the unburnt coal, if you like, and both of those have got enhanced products. So we can make a thermal coal out of the same synthetic thermal coal that is basically made out of the char, but it has the same calorific value as thermal coal. So people can put that in a black coal power station and they're not producing CO2 because it's not in the char. So it's just straight carbon. So there's those sorts of benefits, which are, as I said, CO2 friendly products, as well as generating about 25% of our revenue, which then reduces our operating costs to be cost competitive. And we're always looking at, the only CO2 we emit at the moment is through our using of natural gas for heating, and we're looking to try and convert that over to renewables. So as there's more renewables that come into the electric system, we'll go to electricity to run some of the bigger parts of the furnace and or the spray roaster. And if it goes to hydrogen, we've looked at that with the with our suppliers as well, and they've got a hydrogen switch which they can switch over when that becomes competitive. If we did all that, then you'd have a zero emissions profile. So, we're continually looking at those sorts of benefits to improve our CO2 emissions profile. So, it's I suppose we'll talk about ESG later, but, you can look at that just as a CO2 scenario, but as well as cleaning up the waste that's otherwise sitting in ash ponds and can cause damage or leaching if it goes down, over time.
Yeah, that's so interesting, Dave. Thank you. And we will get to the ESG component in a second. But with the demonstration plant now operational, what are the next steps in terms of scaling up production to the planned 10,000 tonne commercial plant?
So we started already, but now we'll officially press the button, if you like. We have some work to do with GHD on the ash available. We know there's plenty of ash there. It generates 400,000 tonnes a year and has for the last 50 years, but we have to formalise on that. We have the production records. We know where it's gone. So, we have all that, but we have to formalise that, which we'll do. We have to put those processes in. We need to get the data, our emissions data, out of the demo plan, and we can then give that to EPA and the planning authorities. And we have an approval for a 3,000 tonne demonstration plant, so we're only going up 3 times. And in those instances, we were putting in our calculations from modelling at that point in time, which is all you could do, was that we're about half the standards requirements. So good, but we think we'll get lower. So we need to formalise that with getting the data off the demonstration plan. And we don't believe there'll be issues because we had 0 objections with EPA. We had 0 objections to local council because, we do engage with the community, make sure they understand what we're doing. And, we are creating jobs in the valley, which is, it's a hard environment at this point in time with all the power stations closing down. Australian paper, you probably would have seen the reflex paper. That used to make reflex paper, that's closed down. A lot of people with unemployment mounting in the valleys. So we see us as, an employer of the people that, are skilled labourers, so they can easily be adapted to us, our process.
Yeah, that's really great, David. And we've spoken a little bit about the applications of the magnesium product, but in addition to that, which if you wouldn't mind just briefly touching on that a little bit again, just to concretize, but also, just guide us through how you envision Latrobe's magnesium technology contributing to a more circular economy in Australia. So that ESG component that we spoke about a little bit before.
Yeah. So the
application.
The applications are very interesting for MAG, and they always have. The old applications, if you like, is why is China so big? It was desulfurization of steel to make a harder steel and cleaner steel, and it was in the aluminium industry, as we've talked. So China has the biggest steel and aluminium industry, so they had to grow the MAG business, and it grew from 20-odd thousand tonnes to now 1 million. Which is not a lot when you compare it next to the big boys, So, but it's been the third related, but always a cousin because it needs to grow with it. Titanium sponge, you use it, same thing for cleansing, cleaning up. But they're the primary uses, always have been. It's really switched with now the cars adapting the magnesium for sheet production, which only happened around 2016-17 because they couldn't make sheet wide enough to put into a panel before then. So that's why it's been the latest scenario. But the exciting things that we see coming around the corner is solid state batteries you use for magnesium. And when you start talking, Harvard, just the School of Economic and School of Engineering and Applied Sciences at Harvard just came out with their study that they've done in the last few months, and they've said they can adapt it for a smaller if you like, a solid state magnesium battery for a car. And they worked out that you will have 30-year battery life. Pretty impressive. They'll be able to charge it in 10 to 15 minutes. So this is for an EV vehicle, and they'll have 6,000 cycles. You put that next to lithium, and you have probably up to an hour to charge it, and you have 1,000 to 2,000 cycles. So you can see the conductivity, the lightweight helps as well for the magnesium because it's so much lighter. Lithium's heavy. Lithium adds 25% of the weight of a car, the lithium battery. So, you've got those benefits. And they say it'll be Toyota and Volkswagen are looking at it, and it'll be in production by 2030. Harvard study, R&D, so interesting. In hydrogen, and everyone talks about hydrogen, when the costs come down, which will come down over time, you can do the same sort of thing. Magnesium is very light. As I said, it's a third lighter than aluminium. It's 1/3 of the weight of steel, 2 to 3 times stronger. That's why you melt it. So all of a sudden, instead of having big steel containers taking around hydrogen on ships and on trucks, and also that it has to be stored at low temperatures, you can put it into magnesium. You actually infuse it into the metal as a mag hydrate. And you think mag is solid, but there's parts within, and it likes taking the hydrate. Then you add a catalyst, and it will release. Traditionally, you just put water, and it will release the hydrogen, and you've still got your mag. So it doesn't deteriorate. It's a bit like the batteries. It takes 30 years. So there's that, and then there's a whole discussion about automobile gigaplants, which is the latest thing in the OEM automobile business, which is, you meld a whole chassis in one. So you cast a chassis in one instead of putting all those parts together. Beauty about mag, one, it needs it in those parts. Secondly, it adds to the castability of aluminium. So it helps that process. So, we see that as where the future is taking us. I mean, it's been done. It's been done in R&D, and people will pick it up. The Americans have picked up solid-state batteries from magnesium for grid use. You hear in Australia about lithium batteries overheating and being big and having fires. We're just hearing about it probably the last 12 months. It's been happening in the States for a long time. So it's already come out of the universities in the States, and they actually are using it for grid storage because it doesn't have those same issues. So, there's a lot of uses. It's a matter of, do we need it all? No. We just need the current uses, because we talked about suppliers. And the big issue is we're actually the only company in development, what we call development phase. There's a few hopefuls, and hopefully they do get up. And because we see it not as competitive, we just see it as adding to the magnesium, if you like, Western supply chains, which is needed because people don't want to just rely on China. They've had that hiccup that people talk about in rare earths and critical minerals. Yeah. But we felt it. So, the rest of the world felt it. And if you don't produce a reliable supply chain, it just means everyone's going to get smarter and go somewhere else. We don't want that to happen. So we want to make sure that supply chain is kept in place.
So interesting, David. And you mentioned healthcare applications earlier. Would that be something that the company is looking to enter into at all?
Yeah, the healthcare situation is I mean, the interesting part of healthcare is they use it now for stents and other parts. If you have to have 2 operations, so for example, most wrist operations, you have to put something in if you break your wrist, you put something in a stabilizer, takes an operation. Then traditionally you take it out. The beauty about you put mag splints in there, which they do in the USA and they do in Germany now. Don't usually use it in Australia. I don't know why. But they'll put splints in there and they don't have to take it out. So you don't have the second operation, because magnesium is the reason why you take it for health reasons. It adds to your bone density. So your bones will grow back better and bigger, and you don't have to take, and it will not deteriorate, but it will compose over time. So that's why you don't have to worry about it. So that not a big demand because it's small, all the parts are small. So it's a bit like we use it, they use it for, the Japanese use a lot of it for their ultra light computers.
Yeah.
And what we found, it looked like it was going to be a great market for us. But then they started making it thinner and thinner to drop the weight of your microcomputers. And of course, all of a sudden they've halved the amount of magnesium they're using in one computer, even though the number of computers are going up. So the actually amount they're supplying is not required. So that's still good because it's improving the product that people are using it for, but not a big demand driver or supply demand driver. Yeah. So there's all those other benefits which we don't need to rely on. It's a bit like the future ones. So, each one of those would be very big requirements or big demand requirements for mag. But will it? I think a number of them are, have been in R&D for a period of time, and as I said, you have the backings of people like Toyota and VW that want it to happen. And even people like, Tesla probably don't want it to happen because I think they've bought a lot of lithium supply companies.
That's interesting, Dave. Yeah, well, I think given as you mentioned before, there's not that many developers, magnesium developers or producers for that matter in the Western world. You've certainly got somewhat a potential, not monopoly, but a potential, huge demand to fill from a supply side perspective, which is really, really exciting. Now, Dave,
we have been, just quickly on that point, which is a good point. We have been approached because we are in development by probably all the major aluminium sheet producers in the world that you can think of and name. That was to supply them with the bigger plant, the 100,000 tonner. And quite honestly, will we be able to supply them all? No, with the people that we're talking to. So, you can see that it's easy to fill the demand. It's just make sure you get that profile right.
Yeah, absolutely. And very exciting. What a fantastic position to be in, where you've got off-takers sort of all wanting to have a piece of the pie.
Yeah. You can say no to some very big people for a change, for a small producer, for a small company like us.
Yeah, fantastic, David. Now, I just have one final question for you before we finish off, and that is, please, can you provide our small caps audience with just 2 or 3 key investment takeaways as to why Latrobe should be on their investor stock watch list?
Well, I think, firstly, that we've made the milestone that's been made, because making that mag oxide out of the fly ash has been done now. Well, I would say it has been proven. It's as of when was it, 4 p.m. on Sunday afternoon, and therefore the back half we don't see as any issues. So, as I said, we move forward, and that's what all our financiers and people like all the government institutions just wanted to see that happen. Then we can move forward with the real discussions about building a $200 million plant. And then we have a pathway. We have a clear pathway of the 10,000 tonne plant, to go to a $45 to $50 million EBITDA, cost you $200 million, so a good payback period, and that's within, as I said, by the first quarter of 2026. So it's a pretty short time frame. Then we move through to the 100,000 tonne, and all this work's been done now. I mean, we're doing it contemporaneously, otherwise you wouldn't get a $1 billion plant up in early 29. So, that's only 5 years away. And we've already done PFSs with Bechtel, and now we're going to move forward with the other BFSs and bringing in our joint venture partners who are very well-known international players. So all that now starts to trigger the next events. And I suppose that, you know, the other thing for us is just coming back to the critical minerals. I mean, as we all know, there's a lot of money sloshing around the world for critical minerals. There's a lot out of the States. There's a lot out of Australia. We are talking to those people and they have indicated support. So the beauty about that is, yes, you get their support. I'm not talking really about grants. I'm talking really about funding, bigger funding issues, but you get good rates and you get them over right tenure, over you know, more years than a commercial rate. And we have Societe Generale backed up behind all that. So I think we've got all the bits in place. They all wanted to see make the mag oxide, David, and then we'll come.
Yeah, fantastic, Dave. I think it's really important for investors to know that, you know, you've completely de-risked this project, and given you've got strategic sniffing around and you're in the right space at the right time with the critical mineral story, that's very strong at the moment. And in the far future as well. So yeah, again, congratulations, Dave. I've really enjoyed our discussion this morning. And yeah, what an incredible milestone. And yeah, as we spoke a little bit before our interview, you know, really important to celebrate all the wins, the small wins, and now you're going on to the next stage of the company, which is also very exciting. And look forward to having you back on the show to chat about what else the company's been up to.
Yeah, look forward to it. Thanks, Jess.